Newton's first law states a body remains at rest, or in motion at a constant speed in a straight line, unless it is forced to change its state by a force acting on it. This law only applies to linear movements, which hardly exist in reality. It is therefore not perfect. In fact, straight lines are a special case of curves. This means that if the radius of a curve is infinite, it becomes a straight line. Similarly, linear motion is a special case of curved motion. The general state of motion is curved motion, which also becomes straight when the radius of the curve is infinite. This means that there is no clear boundary between straight and curved motion, they are continuous. In some physical theories, straight and curved motions are treated as two unrelated states. This view alone is an indication that such a theory cannot be perfect, if not wrong. A perfect theory must be able to explain the rules of motion in the general state, i.e. in the curved state, and it must also apply to the rules when the radius is infinite, i.e. for linear motion. We have presented the properties of inertia in detail. Every body of mass has a natural property, inertia. The essence of inertia is that every moving object remains in its state of motion in order to resist the external forces acting on it. The actual magnitude of the inertial force can be expressed as explained by the following equation. If the radius is infinite, the curved motion becomes linear and the inertial force is zero. And so back to Newton's first law. If inertia is integrated into Newton's first law, this has become perfect, and Newton's first law is generalized. Newton's first law should then read as follows: a body remains in its state of motion with its inertia against the forces acting on it, which force it to change its state. Newton's first law is often referred to as the law of inertia. Only now can this generalized first Newton's law really be called the law of inertia.